Hello, hello, hello. Welcome to our talk. Yes, this talk is going to be about Grafana Alloy, OpenTelemetry, and Prometheus, and how we're bringing them all together. Just a reminder, you can ask questions at the end. My name is Ted Young. I'm one of the OpenTelemetry co-founders, and I'm a developer programs director here at Grafana Labs.
And I'm Johanna Eyeling. I'm a senior software engineer at Grafana Labs, working on the fleet management team.
Cool. Okay, so what is Grafana Alloy? If you look on the back of the box, it'll say that Alloy is a high-performance telemetry processing tool and a successor to the Grafana Agent. So that's nice, but what does it actually do, and why should we be bothered to use it? And the answer is telemetry processing is a natural part of any observability system. And that's because we take these applications, we start in this sort of beautiful greenfield world, and then they slowly move across their life cycle into legacy, right? So like our systems are constantly growing and evolving, and because of that, our telemetry is a bit of a moving target. And over time, there's some cruft and modifications and things that builds up, right? You have old formats, but then new services or applications or data sources come online, and they have a different format. So you want to change formats, combine formats. You might have a library that changes versions, and the data it emits changes a little bit, but you still want the old dashboards to work. So you want to normalize that data and massage it. You might also have privacy or regulatory concerns that you're trying to deal with, and PPI is a really important concern these days. And all of these things are things you do in a telemetry pipeline. You also want to create new data from old data. The most common thing here is creating new metrics from other data sources like logs and spans. And then there's the fact that telemetry itself is kind of a big data system. Big systems can produce a lot of telemetry, and you end up having to operate that telemetry pipeline and do all of the normal things you would do with a big data system around buffering, reducing the amount of data you're sending through sampling, load balancing, all of that stuff. And you want to do all of those things in one tool. You don't want to have a bunch of little tools all doing different things. Having one big tool that can manage all of this for you is really helpful. So essentially, Grafana Alloy is like an observability Swiss Army knife. I mean, you could call it an observability Swedish fish knife, a little bit more accurate, but doesn't quite roll off the tongue. The other thing that it does, though, is it works as an alternative implementation to the standard OpenTelemetry Collector. Why does it do that? And what does that actually mean? So OpenTelemetry has something that's very similar to Alloy. It provides telemetry pipelines and processing and all of that stuff, and it's called the Collector. So how is it that Grafana Alloy is also an OpenTelemetry Collector? To understand that, I need to give a little bit of a history of the OpenTelemetry Collector project. So this is a little abstract, but I think it's actually important to understand because you're going to hear the words OpenTelemetry Collector and OpenTelemetry Collector distribution get thrown around, and it can be a little confusing about what those terms mean because we've been using them somewhat casually and colloquially in the past. And we decided a while back that we needed to actually lock down this definition and make it rigorous so that we could allow for alternative implementations like Alloy to exist. But it turns out when you start to ask what a collector is, it's a little bit fuzzy. Same thing with the collector distribution. The reason why we didn't have a strict definition for these terms is it turns out it's not so easy to come up with one that works exactly the way we want it to. You know, you could just point at the collector code base in the OpenTelemetry GitHub organization and say, like, that's the collector. But then when we look in the real world, there's all these things that we'd like to call a collector that have had to take that code base and tweak it or modify it in some way in order to make it work for them. So we don't want to say it has to be exactly that code base. That wouldn't be helpful to us. Is it a set of APIs? Another model we could look at is the Kubernetes certification program, where they say if it quacks like Kubernetes, then it must be Kubernetes. So they have a set of rigorous API tests. Anything that can pass those API tests is Kubernetes. That doesn't exactly work for us, though, because the OpenTelemetry Collector is a collection of plugins. We don't really want to say you have to support exactly this plugin or that plugin. Even things that are core to OpenTelemetry, like OTLP, OpenTelemetry's native format, We don't want to say a collector has to have OTLP embedded in it. There's plenty of reasons why it wouldn't. For example, if you're running on Lambda, talking to X-ray, you don't necessarily need OTLP, so we don't want to say that thing isn't a collector just because it didn't have that particular API. What we landed on was we want portability. We want people to be able to move between these different collector distributions without having to do a lot of work or feeling like they're stuck on one distribution versus another one, right? We want it to feel like one coherent ecosystem, not a fractured landscape of competing projects. So we decided the goal here for our definition was to allow these different collectors to be drop-in replacements for each other. As long as something could drop in and replace another collector with the collector functionality, it was fine for it to offer additional functionality that they didn't all have. So what is this functionality that we want to support? The first are these collector components. These are the plugins. Now, if you go to different vendors, you'll notice that they often say they only support a certain subset of plugins, and what they're usually talking about are SLAs or support contracts. They're saying, you know, if you use these plugins, we'll provide you support. If it's just this random plugin you found on the internet, not so much. And that's totally fair, but we do want users to be able to choose which plugins they run, regardless of that support contract. So it's very important that people can write their own plugins, have their own set of stuff that they're using, and if they switch collector distributions, to be able to bring those plugins with them. Related to that is the configuration file. You're taking all of these plugins and you're configuring them into these pipelines, and that can get pretty complicated. You want those pipelines to come with you as well. So it needs to be the case that if you're moving from one collector distribution to the other one, that configuration file is supported, and most importantly, the behavior stays the same between these different pipelines. So as long as something can do both of those things, that makes it a collector. That's our current running definition. We're going to see how it goes. So that's great. That's what a collector actually is. But why is it that Alloy wants to be a collector? And the reason is lots of people are running OpenTelemetry, and they're using the collector to handle a lot of these pipelines and processing problems that we were talking about earlier. And we want to support people where they're at. We don't want them to have to do a lot of work to adopt Grafana Labs. So we want to go where they are and say, like, hey, if you're already using the collector, it's easy to switch to Alloy. At the same time, we have a bunch of features that aren't available in the upstream collector. And it would be nice if we can upstream some of them eventually, but currently they only exist in Alloy. And so we want to offer those features as well. So one of these features is live debugging. And I'd like to give a demo of this along with showing how OpenTelemetry actually works, or sorry, how Grafana Alloy actually works as an OpenTelemetry collector. All right, so let's switch over to the laptop here. All right, here we go. I'm just going to run this as a video. Hope you don't mind. So what we're doing here is we are looking at the OpenTelemetry demo project. By the way, if you're trying to learn more about OpenTelemetry, this demo project is a great way to do it. You can find it on the website, OpenTelemetry.io. And so the way this works is it's a whole bunch of different services that are loaded up into a Docker Compose file, including this here, which is the OpenTelemetry Collector. So here we can see the Docker definition for the collector. And then here is the configuration file for that collector. So this is the standard OpenTelemetry Collector Contrib distro for the collector. It's got a couple of receivers, processors, and exporters, and they're organized into a relatively simple pipeline. All of the data coming out of this demo application is going to run through that collector on the way to the back end. So we're going to start the demo up. We're going to wait for OpenSearch, as usual. OK, now it's running. So we can go to localhost 8080 and have a look at what this demo actually does. And it is an observability store where you can find all of your observability needs. So here we have a solar system color imager. Definitely need at least 3 of those. And it's your usual kind of checkout, processing pipeline. So this is a great little tool to understand how OpenTelemetry works because we've got services in all these different languages running. So if you're wondering how to set up OpenTelemetry in a particular language, I actually recommend looking at this project. But here we're going in and checking out the collector. And we can see that data is getting processed through the collector because we can see the logs. But it's a little hard to understand what's actually going on, right? Like you can read these logs, but it's hard to get a coherent view of what that configuration file actually turns into in the real world. So to get a better sense of what's actually going on, we're going to swap the collector out with Alloy. So all we're doing here, because it's, again, a drop-in replacement, we're changing the image to Grafana Alloy. 1.8.2 is the latest version that supports these features. And then we're going to grab the Grafana command line. It's a little bit different from the collector's command line, but just to walk through it, you're using the run command. You're setting the configuration format to the OTel Collector format. We're going to start the diagnostic server up. We have to set the stability level to experimental to support these features because they're relatively new. And then we're going to point it at that same collector config file. OK. So we're going to redeploy the collector. Draining the old one, starting the new one. There we go. Now we're going to go have a look at the logs again. And you can see there are logs coming in. They're slightly different, so we know it really is Alloy running instead of the regular collector. But now, because it's Alloy, we can go have a look at this handy diagnostics tool that tells us all of the different plugins that we're currently running. So here you can see everything that's loaded up, but there's also this awesome graph view. So what this has done is it's taken that config file and it's shown the actual pipeline that's being generated out of it. So you can see data flowing through it. You can click into each one of these components. You can see how it's been configured. You can see whether it's healthy or not. You can see its dependencies, what it's connected to. And this is a really handy graphical way to understand what's going on. I find this is especially useful when you're in development, actually modifying and creating these pipelines to kind of double check whether or not what you did actually is what's expected. And when you're seeing the data flow through it, that can give you a clue as to whether or not it's actually processing the data the way you'd want it to process. OK. That's the end of the demo. Let's go back to the slides. Great. So that's what we do when we want to support OpenTelemetry as a collector. But what about all those other handy features we were talking about?
Well, the first thing I want to talk about is native Prometheus pipelines. So if you want to observe your infrastructure and you expose metrics in a Prometheus format and want to send those to a Prometheus backend, then you may not want to convert the data between different formats when it's Prometheus all along. So for these use cases, Alloy offers the possibility to create native Prometheus pipelines to give you the best performance. And Alloy supports a number of popular Prometheus exporters, whether you want to export metrics for your databases, like Postgres, MySQL, or you may want to use the node exporter for exporting system metrics, or even metrics from other monitoring systems, like those offered by cloud providers, just to mention a few of the exporters that Alloy supports. And to build a Prometheus pipeline, we use the Alloy Prometheus components. In this example, we want to export our local system metrics using the embedded node exporter. So we use the Prometheus exporter Unix component. We scrape those metrics with the Prometheus scrape component, set the scrape interval to 10 seconds, and forward them to a Prometheus relabel component. And here we apply some filtering, where we drop the metrics for our dev environment and forward the other to the Prometheus remote write component. And this takes care of writing the metrics to our Prometheus compatible database. So by combining the Alloy Prometheus components like this, we can construct our native Prometheus pipeline. Next, I want to talk to you about one of the news from this recent year, and that is fleet management. Now imagine that you're running hundreds or thousands of Alloy collectors that are run in different environments and used by different teams. That can be quite challenging to manage, and it can be a tedious task when you need to roll out any new configuration changes. Let's say that we have deployed a number of Alloy collectors using the Prometheus pipeline that I showed you earlier. And we set the scrape interval to 10 seconds, but we notice that this generates too much data, and we actually only need to scrape the metrics every 60 seconds. So we decide to change this. Now we need to go in and reconfigure every single Alloy instance where we deployed this. Wouldn't it be convenient if we had a central place to go to, where we could get an overview of all of our collectors and configure them remotely? This is exactly why we introduced Alloy Remote Configuration and Grafana Fleet Management. When using the Alloy Remote Config option, we can configure Alloy to, instead of reading configuration from a local file, fetch it from a remote endpoint and continuously look for updates and load these to a running Alloy instance. And this communication between Alloy and the remote server, it's based on an open source protocol available in the Alloy Remote Config GitHub repository. So you could build your own remote server and use, but we also provide a managed service for this in Grafana Cloud, and that is Grafana Fleet Management, which is free of use. What Grafana Fleet Management does is that it provides an interface that gives you an overview of all of your collectors and their current status. So you can monitor their health, you can inspect the logs, and you can configure them remotely. You can assign your collectors attributes, like which team that owns them or which environment they're run in. And you can apply configuration pipelines to your entire fleet of collectors based on the attributes. This can save a lot of time when you don't need to configure the collectors individually, and also allow for safer rollout, since you can apply the configuration in stages and also easily roll it back if something didn't go as expected. One of my favorite use cases is data collection on demand. So under normal circumstances, you may not collect logs on a debug level, and if you collect traces, then you may apply some sampling. But when there is an issue that you need to troubleshoot, sometimes it would have been nice to have that detailed data after all. Well, fleet management can give you that. So you can prepare configuration pipelines for data collection. Like you can have those logs on debug level and traces like 100%. And when you need that, you just activate those pipelines. Once you're done with your investigation, you can easily switch them off without having to redeploy any collectors. So this gives you control over costs, while at the same time gives you access to the data that you need when you need it. Okay, so we talked about Prometheus pipelines and fleet management. Let's have a look at how this works in action, and I will show you how to configure this pipeline that I showed you earlier to export the local system metrics from my MacBook. Right, so we start with configuring Alloy to use the remote config option. We set the fleet management endpoint, and we give this collector an ID. I call it GrafanaCon 2025. We start Alloy. You can see that it's running. And we can go to the Alloy UI to see which pipelines it has picked up. Check the remote configuration tab, and we see it's currently using 2 remote pipelines. These are enabled by default to monitor Alloy itself and export its metrics and logs. If we have a look at the fleet management UI, we can refresh the page, and we see that our GrafanaCon collector has connected. Can get more details about its health. Can check the logs. And we see here that it picked up the self-monitoring logs and metrics pipelines. We can check the collector attributes like its ID, OS, and the Alloy version that is running. And to create a new pipeline, we go to the Remote Configuration tab. Here we can also see all the pipelines that we currently have and what their matching attributes are. If we want to create a new pipeline, we can either choose from a template or create a custom configuration. And I prepared a pipeline here which is very similar to the one that you saw earlier to export the local system metrics. So we copied this configuration pipeline and we pasted it to the fleet management UI. We also need to give this pipeline a name, so I'll call it Node Exporter macOS. We can verify the configuration syntax. Looks good. And now we need to select which collectors to deploy it to based on the attributes. So I choose OS Darwin, and we can see that it will be rolled out to our Grafana collector. Finally, we need to activate the pipeline. Now this should be picked up by our locally running Alloy instance. So if we refresh the page, we can see the Node Exporter macOS pipeline appear here. We can have a look into its individual components and whether they are healthy or not. And if we look at this scrape component, we will see here that we set the scrape interval to 10 seconds. If we want to change this, we need to do it remotely. So we go to Fleet Management, edit our pipeline, and we change the value. I'll set it to 30 seconds this time. Test the syntax. And it will still be deployed to our Grafana collector. OK, looks good. So now Alloy should detect these changes. And if we refresh, we see that it will now export metrics every 30 seconds. Finally, let's verify that we're actually sending these metrics. So we go to metrics drill down, check the last 5 minutes, and filter on the node metrics. And we can see that data is being sent to Grafana successfully. So our pipeline worked as expected. OK, so we can go back to the presentation. All right, you have heard about some of the features that are already available in Alloy. Then what comes next? First, we're happy to introduce further improvements to the Alloy UI and debugging experience. The line graph that Ted showed you, we will make that available also in Fleet Management for remotely configured components. And in the Alloy UI, we're going to introduce a new tool, Alloy Diagnosis. This will analyze your configuration pipelines and identify errors and bottlenecks and advise you on optimizations for your pipelines. And we will continue to invest in the OpenTelemetry capabilities of Alloy. And for fleet management, we will introduce OpAMP capabilities that is also part of the OpenTelemetry ecosystem for remote management of telemetry agents. And these are just some of the features that we are excited to bring to you. There is so much more.